Hey, Dr. C here with you. So, does 5G cause COVID? Um, yeah, it's a crazy time. Early in this pandemic, I feel kind of naive for even thinking this, but I was hopeful that just the gravity of the situation and the novelty of it and the need for scientific discourse would cause a lot of bad ideas to go by the wayside. And I don't know, I felt like we could really get behind the scientific consensus and figure out what was happening and take all the best precautions. And, I thought it could be a time in which we really moved away from bad ideas and could really realize that the quality of information matters. And now that I look back, I feel really naive and silly. The evidence is strong that in situations of urgency and strife and conflict, people don't tend to really give up on their views. They often go deeper in them. And so now what we're seeing is a lot of thought about various conspiracy ideas, that COVID was planned, that it was intentional. And a lot of these marshal around the idea that somehow 5G, the wireless technology, was part of propagating the virus. One of the arguments is that in Wuhan or in Italy, areas that were hardest hit were also areas that were early 5G adopters. And so it's put out that there was, cause and effect correlation. Wuhan, China had such illness because they had a lot of 5G in their area. And that's how the argument goes. Tough thing is that, South Korea was also an early adopter for 5G, but they did really well against COVID. So the arguments for this, apart from just, correlation in this region or that region, there's three main things that I've seen. One is an argument that 5G technology absorbs oxygen, and with the issue of COVID affecting the respiratory function, that it makes that more of an easy of a problem. If someone has compromised respiratory function and they've lost oxygen, they're going to be more symptomatic and more apt to die from it. So that's one argument. Another one is that 5G is used in some way to transmit the virus, or that it passively spreads the virus more easier. It carries it around somehow. And the last one is that 5G suppresses the immune system. Now, the first couple ideas I won't spend a whole lot of time on. The most elementary understandings of science show us that 5G technology cannot absorb oxygen, nor can it break down oxygen. I'll talk a little bit more about that. Also, wireless electromagnetic fields in general, there's no way that we know of, no way by the laws of physics by which they could carry anything physical, living or non-living. So those two are pretty easy to let go of. But 5G suppressing the immune system, I'll spend some time on that. There's some ways in which one could argue plausibility behind that, and many credible people have been on both sides of this. So let's talk a bit about this. And I want to acknowledge the psychology of this too. It's unsettling to feel like there's these massive impersonal multinational corporations that don't care about us, and they're shooting these powerful waves all around us any given moment. And radiation, it's a scary word, it's a loaded word. So this is a valid thing. If we take this down and narrow this, we've got to think about, first off, just some definitions. We've got radiation as a big concept, and all electromagnetic waves are categorized as radiation. This is a case to where the specialists use words different than everyone else does. Like when a doctor says a tumor, most people think, oh my God, that's cancer. But to a doctor, that means a lump. And most lumps are benign. And in this case, radiation means all these fields, most of which are harmless. But yes, there's a subset of radiation that certainly can be dangerous. And we call this ionizing radiation. And the basic difference comes down to the wavelength. So radiation, in the broader sense, it's kind of an odd thing. There's some particle that's carried like a wave. And how far apart the crests are of that wave determines a lot of its properties. It determines how much energy it's carrying. So these waves, they all cover a distance at the speed of light. But if they've got a short wavelength, you can imagine like pulling a straight string. So if you've got a string that goes from here to here and it goes up once, right? That's going to be a little bit longer. But if that same string that goes from here to here goes up and down 1,000 times, that's a really long string, right? So that's how these things work. And because they cover the same distance, they carry more energy when they have a shorter wavelength. And if their wavelength is so short that it's smaller than the size of an electron cloud around an atom, it could actually crest inside the atom, and it could bing that electron out of place, and it can cause an ionization reaction. It can cause a chemical change. Now, any kind of a wave can cause heating. It can cause a thermal or a physical change, but only ionizing radiation can cause chemical changes, and that's because it's got a short enough wavelength. So the question is, now, many who have talked about the dangers of EMF, they've gotten a little more sophisticated, and they by and large acknowledge that yes, non-ionizing radiation is not going to ionize. They acknowledge that, and that's pretty straightforward true. But the question comes down to, can non-ionizing radiation do anything? And by non-ionizing radiation, we're excluding things like the cosmic rays, the gamma rays, the X-rays, and then the weakest ionizing version of radiation is UV light. And that's why, when we get sunburned, there's a couple things that go on. The burn itself is really not so much from UV light. The burn more so is from the heat and the infrared light. But if you get enough sun to burn, you've probably got enough sun to have UV light damage the DNA of your skin cells. And that's where the cancer risk comes in from, because the UV light can penetrate and it can cause a chemical change to your DNA. And that's why we are concerned about that. But once we move past outside that ionizing threshold, now it's all non-ionizing radiation. So those who say that we have dangers to think about, they make an argument that non-ionizing radiation can still have effects on living things. And one more little distinction to make here. So stay with me, we'll get through this. One more distinction to make is that any kind of radiation, if it has enough power behind it, there's enough amplitude and enough actual just force behind it and power, it can have a thermal effect. So it can warm things. So that's how microwaves work, and that's how really infrared light heats things as well. Heat is transmitted by electromagnetic waves of all sorts. And yeah, they can warm. Now the warming takes rather dramatic amounts, and the EMFs that we think about, like cell phone dangers or whatnot, those really aren't through warming effects, and few would argue that they are. Like, for example, if you were concerned about the effects of your Wi-Fi router, it's not hot. It's quite objectively, you don't get heated up by being in an adjacent room to it. I've got a router upstairs away from me. It's not heating this room. That would be quite measurable. You could actually know that you were hotter the closer you were to it. And that's just not the case. So then the final question really comes down to, does non-ionizing radiation have non-thermal effects on living things? So that's our final stop. No one intelligent is debating about ionizing or non-ionizing radiation. Pretty much everyone gets that, even those who are against this. And few of them even debate about thermal or non-thermal. They get that, yeah, we're not talking about a powerful enough EMF to heat or cook things. That's not really on the table. But the final question is, can these fields do something when they're not of a sufficient force to generate heat, and they're too long of a wavelength to cause ionization? So that's the core question. There was a real popular book that came out very recently, and I always struggle with this stuff because this was written by a friend of mine. A lot of these things that are coming out are people that I know, and they mean well. They put out a lot of good data, but the book basically said that it agreed with all these things that I stated. It was saying how, yes, non-ionizing radiation can't have the DNA damaging effects. It argued also that it can't make free radicals. However, it argued there's a different kind of free radical. That the main type are hydroxyl free radicals that can form within cells. But this book argued that carbonyl free radicals can be formed. And that once this book opened up that idea, it's basically saying that, yes, non-ionizing radiation, even when it's not having a thermal effect, can still cause chemical change by carbonyl free radicals. Well, and it basically says this is a reaction that's often not understood or not thought about or considered, and it's often ignored. Well, so just a real quick discussion about that. It's a known thing. There's a lot we have yet to learn, but there's so much that we do know right now already. And that's one of those. We do know that, yes, EMFs can cause carbonyl radicals. However, they're known to be caused by UV light. So we're back to ionizing radiation again. This is called a Norrish reaction. So yes, carbonyl radicals can form by a Norrish reaction when UV light is interacting with living things. but that doesn't occur by the non-ionizing radiation. And the concerns about 5G, EMF, Wi-Fi in general, these are all things in that non-ionizing category. They're all things that are not short enough wavelengths to cause ionizing effects. And in this book, it made that one distinction early along, and then it kind of ran with the idea of carbonyl free radicals, and it just based the whole book off of that. But that first principle was just not valid because it doesn't apply to non-ionizing radiation. So how is it, though, that so many can claim they have studies showing that 5G can be harmful or Wi-Fi can be harmful? And the cool thing is that at least now, I think everyone realizes that you can't just argue and say this is true and leave it at that, like because I said so and I'm an authority. I think that most everyone who's making claims like this, they realize that they have to have some basis in fact. They have to refer to evidence or some studies or some citations. That's a cool step. But let's think this through. We now know we need proof, right? But we know in our own experience that proof and evidence, it's not all equal. And it's honestly the same thing in scientific literature as well. And I'm not even saying that things are inherently wrong or goofy or bad, but the big decisions are made not by one or two pieces of data, but by the preponderance of evidence, by all the things we piece together at an overall look. And I think we really understand this intuitively when we look at product reviews. Let's see, what's something that I got recently? Okay, so I'm doing more of my own groundskeeping around the house here as of late, and I got a blower for that purpose. I had to get a blower to use, and we look at product reviews, right? So what's one thing you look at when you think about product reviews? Well, how many reviews are there? If you've got a lot of high reviews, that's more meaningful than a smaller number of low reviews. So we have this sense, but also we think about the quality of sources. So let's say there was two things you were choosing from for a product purchase, and they both had similar ratings and a similar number of reviews, a low number, but you could see that some of the reviews from one product were from anonymous sources, and the reviews from another product were from well-respected reviewers. So the anonymous sources, it might have been, the mom and the siblings of the person who was selling that thing, right? They could have just put some basic review on there and not really gone into it. And we get that. We understand that all sources aren't equal. And it's the same thing in the scientific process. So the difficulty is that we look at things with two different lenses. If we have an idea that appeals to us for some reason, that we, even if not consciously or deliberately, but if part of us wants an idea to be true, right? We have one way in which we look at evidence compared to that idea. And I call this the can and the must distinction. I'm sorry, I don't want to make I've made that up. Jonathan Haidt, I think he coined this concept. It's a great concept, but it's a can and a must distinction. So on one hand, if I have a pet theory and I see evidence that supports that theory, I'll look at that and I'll think, can that be true? Can I believe that? This supports what I already believe, so can I believe that? And when we look at things in that way, we don't scrutinize them closely at all. We think, yeah, that makes sense. That fits what I believe, so that must be a valid study. And we just grab onto it and hold it. But the other thing we do is that if evidence goes against what we believe already, then we give that a different criteria. We give that the must criteria. And that's must I believe it? Is there some pitfall, loophole, error, weakness somewhere in that argument? And if we find something like, who funded the study, or how long was it done for, or whatnot, was Bill Gates behind that? I'm being silly here, but once you see something that you could find in your mind could give you cause to question that, we can easily dismiss it. So that's the process. We have things that we support that support our current beliefs. We say, can I believe that? And the things that go against our current beliefs, we think, must I believe that? So that's one big issue we're up against. But then, even then, okay, so how can it be that there's even studies that exist that suggest that 5G could be harmful if it's not? Well, this is bizarre stuff. And actually, this is something that I found out in just researching this video that I'm doing for you right now. There have been a lot of studies, of course, looking at the effects of 5G on living things, we call those in vitro studies, and then non-living things, we call those in vivo studies. So basically you've got some chemicals in a test tube or some cells in a test tube, and you expose them to 5G, and you see if there was some kind of a response. And not even saying perhaps good or bad, but just did something happen? Did they change their polarization? Did they change the rate of a chemical reaction? Did something occur? And yes, the scientists know that if you give enough power behind the wavelength, it'll eventually heat and something will happen. But no, so non-thermal, we're being fair. So with non-thermal, non-ionizing 5G type of radiation, can something happen to things in a test tube or to actual living things? And the fascinating part is they've done a lot of sham studies. So what does that mean? Well, let's say that I'm wearing my white coat and I'm a researcher and I'm watching these cells in a dish and I'm looking to see if there's signs of a chemical change. And there's a machine, there's something like, let's say there's a machine that's emitting a 5G wavelength and there's a light showing the machine is on. And if the light is off, the machine is off, the light is on, the machine is on. Okay, and I see that, I'm aware of that, and I'm recording these cells. And I say, okay, the machine's going, I see this happening, the machine is off, I see that's happening, and I record my observations, right? But what if the light on the machine was fake? What if I was wrong about when the machine was on and when the machine was not on? What if I was tricked? What if the light was on, but the machine wasn't emitting 5G, or vice versa? What if the light was off, but the machine was emitting 5G? Would that change my observations? And this is so fascinating. A lot of observations that we get, even on things that seem very objective, like chemical reactions on cells in a test tube, they still come down to human judgment. And when scientists are making those distinctions on things that are in test tubes, non-living things, they are tricked by shams. They don't get consistent data when the data is when it's a sham, when they're tricked about whether the machine is on or not. In fact, 68% of the time, scientists are misled by sham information about 5G. So if they're evaluating non-living things, cells in a test tube, living things but not in a larger system, they can be giving wrong information just based upon their expectation of whether they're exposed to 5G or not. So what about actual living things? What if they're talking about, mice or animals of some sort? Well, it gets a little better. It's 50%. It's actually a coin toss. So if they don't know that they're seeing sham data about the exposure of 5G, they're wrong half the time. There's an image I'll share in the blog post about this, but yeah, I want to just go deep on this and make this really clear. So most studies that look at the effects of EMFs on living things or non-living things, they don't have a sham component. They're just saying, what do the scientists observe? And I think I would have been inclined to think that those observations were just straightforward. Maybe a few percent of the time there's just errors or whatnot. But no, when there are studies done that look at sham exposure to EMF, they're wrong the majority of the time when it's test tube data, and half the time when it's living things. So this is kind of like a placebo effect in terms of whether a pill works or not. If we know that, let's say if we know that a placebo works 30% of the time and a new drug works 30% of the time, we would say the drug didn't work. Even though it worked 30% of the time, we would know that 30% was no different than the placebo effect. And if the drug worked 50% of the time, we would know that was probably only 20% because 30% came from nothing. 30% was just a placebo. So since so many studies do not have a sham element, we can't take that data as seriously. Or if they did have a sham element, we would give a higher threshold, right? So studies show that most studies that show there's some effect that 5G has on living things, they never show that it happens all the time. They show that it happens sometimes. But it would have to show that it happened way more commonly than you would expect just by sham data. And that hasn't occurred. The threshold has been well below that sham threshold for in vivo and in vitro data. But those types of data exist. And so yes, if you don't bother yourself to look at the whole preponderance of evidence together, and you just want to find a study to support your pet belief, you can find information that supports that. But if you're doing critical analysis, you're not forced to believe that data because you've got to take into account the sham effects. and the sham effects are huge. Let's talk a little bit more about what really is 5G and what it is that we're thinking about. So this is an example of microwave radiation. And now that's another loaded term, right? Microwave sound really scary, but it really just means we're talking about millimeters to centimeters. So like, say 1/8 of an inch to 10 inches. There's a certain range, and don't quote me on that, but we're talking about wavelengths that are in the range of generally millimeters or centimeters. And these are waves that they do carry fields, they do have thermal effects, and they can be used to relay messages, which is why they're useful for phones. And the 5G, it's actually a longer wavelength than 4G or 3G. So in the spectrum of radiation, the scary stuff is way over here. 5G is further away from that. It's further away from the scary stuff than the older technology is. Yeah, and it's actually so weak that it can't go very far. It can't really go around things. It can't go through things. And that's why they need to build more 5G towers, because they're not very strong. The waves don't penetrate. They don't have a lot of distance. They're weaker waves. They're longer wavelengths, but they are able to carry larger amounts of data, which is a great benefit. But yeah, no real information about them having effects on tissues because of that high sham response. Now, they can have thermal effects. They can have warming effects, but that's really limited to being right up against a source of the 5G. So if you were literally inches from a tower, you could feel some warmth perhaps on your skin, but these things cannot penetrate even the most superficial layer of skin. So like the background scatter images taken at airports, they can't see, you can't see your bones from that. They can't get in. And so since they're only acting on the surface of your skin, all they could do is warm if you're right up against there, and you would feel that. So this is something that, yes, it comes from the 5G towers. That's a newer technology, and they're putting in more towers because it's weaker. It can't cover as much distance as 4G does, so you need a greater density of towers to cover the same area. So where else would we get these? Where else could 5G come from? And in general, EMFs, these fields in general, anything that gives off heat gives off a mixture of electromagnetic waves. And per the material, per the level of heating that it has, that could be some combination of infrared, that can also be ultraviolet, that can be microwave heat. We can see some mixture of these things. And then extreme sources of heat can even give off the ionizing radiation, like more UV or X-rays. So if you really want to avoid 5G, what would you have to do? Well, so let's say you're just not sure, and okay, Dr. C, you kind of make sense, but I just want to be on the safe side. Okay, well, here's what you got to do. I'll tell you now, it won't be easy. So you've got to stop cooking food. And here's why. Campfires, gas stoves, electric burners, they all give off 5G. They all generate microwave radiation. They all generate infrared heat. Of course, microwaves generate microwave radiation inside of them. They also do give off some infrared, and you could see that. So yeah, you can't use heat anymore because that will expose you to 5G. The other problem is you don't want to be around people anymore. Yeah, humans give off 5G radiation. We also give off infrared radiation. We even give tiny amounts of visible light, far too little to see. But yeah, we give off non-visible, non-ionizing forms of radiation. And simple proof of that, if you've ever seen a military movie where they use the night vision goggles, that's what they're looking at. Humans are giving off these versions of non-visible, non-ionizing heat. But microwave EMFs are also part of that, along with the infrared. So yeah, we give that off. The other thing you want to do to avoid 5G, you got to stay inside. Our atmosphere generates a fair amount of 5G waves as it's heating, as we have differential heating of the photons from the sun moving through it. Oh yeah, and the sun, by the way, the sun gives off a lot of 5G microwaves. So stay indoors, you got to stay out of the sun. But there's one more problem. So it's not just not cooking, and it's not just staying away from people, it's not just staying inside, and it's not just staying away from the sun. There's one last step you got to take, and it's going to be the trickiest one. So somewhere around 1948, scientists were postulating the idea about the known universe being compressed in one point and then violently expanding from there. And as an example, so this is how science works. They try to disprove their theories. And the things that can't be disproved are then left and held onto. So one of the first attempts to disprove this idea, which later became called, disparagingly, was called the Big Bang Theory. So they said that, well, if that was true, that the whole known universe would have to still be radiating, would still have to be giving off some version of waves. And a fun twist of coincidence, they said, look, if it really did happen, 13.7 some odd billion years ago, and the whole thing's been expanding and cooling since then the waves that would be given off now would be in the microwave spectrum. They would be 3 to 90 gigahertz, and they should be present anywhere you look. So check it out. That's 5G. That's squarely in the 5G continuum. And this was put out in 1948. They had no means to test that, but it was basically saying, yeah, this is not likely true. Otherwise, we would have this observation. By 1964, instrumentation improved. And they found that everywhere you look, every part of the known universe, there's a background signal going on. There's this background echo still occurring, and it exactly fits the wavelengths that were predicted in 1948. So the whole universe is resonating with 5G waves. I can't make this stuff up, you guys. So yeah, you got to leave the whole known universe. And so someone who could hear this could say, sure, but those are all examples of weaker 5G. That's my point, right? So there's thermal and there's non-thermal. And if you're talking about 5G or infrared or UV or visible light, if you're talking about it strong enough to have a thermal effect, yeah, that can heat things. No debate about that. And if we're talking about radiation that's ionizing, yeah, that can ionize things. That can be bad. But if we're talking about non-ionizing, non-thermal radiation in the 5G microwave wavelength, radio wave wavelength, whatever else, there's no known ways that those can cause any effects upon living systems. Only if you ignore the idea that there are sham effects. So scientists that don't know if the machine is actually really radiating or not. If they think it is and it's not, we might see something show up. Once we exclude that, we've got no more findings to really go on. So yeah, we're around that all the time. We can't be away from it. And these things don't have biological effects. I don't turn off my Wi-Fi router at night. There are magnetic effects that EMFs can have, and there are the thermal effects. But yeah, those are highly limited by distance and power. So you wouldn't want to have your head right up against a wall that contained the circuit breakers for your home. That can generate some EMFs. And the earlier cell phones, yeah, it's not great to have that cell transmitting and running right there. Having said that, there is a thermal, a warming effect from that. But even in that scenario, that thought about, could that be a risk for brain cancer? So this has been studied so much. And the simplest piece of data is the fact that, in 1980, for example, exactly 0% of the world's population used cell phones. Let's make it even better. Let's say 1960, definitely 0%. And then by the year 2000, 2010, we've got half, 2/3 of populations using cell phones, like a lot, like living on them. So if that had any effect upon brain cancer, there should have been some change, no matter how small, in the global rate of brain cancer. And if there was a change, there might be some plausible arguments why something else could have caused that, right? But if there's no change whatsoever, it's hard to make a claim that cell phones could possibly cause brain cancer. And that's what we've seen from 1950, 60, 70, 80, 90, 2000, 2010. The rates of brain cancer have not budged anywhere globally, not one iota. And if cell phones contributed, we'd have to have more brain cancer when the whole world uses cell phones than from before, when no one ever used any cell phones. There's no new cases. So this is not something that I'm worried about. And there's just no possible way that 5G could suppress your immune system, take away your oxygen, or carry the virus around. So yeah, I'm not a factor. Just wanted to give you some peace of mind and talk through that and let you know that it's not something that's worth worrying about or putting too much thought into. All right. Take great care. And I'll see you soon. Bye-bye.